I'm Brian Creer, tutoring high school physics. Today's topic, the photoelectric effect. So what is the photoelectric effect? Something pretty cool, actually. If you shine light on some piece of metal, then electrons are going to be ejected. So what's actually happening here? Consider light to be a beam of particles known as photons. These photons are going to carry some sort of energy, and then they're going to bump into electrons, transferring that energy. If that energy is enough, then the electrons are going to be ejected from the metal. So how do we find out if that energy is enough? Well, we have this equation over here. Energy is equivalent to Planck's constant times the frequency. So Planck's constant is a constant. It's always the same. 6.63 times 10 to the negative 34 joules seconds. Or alternatively, 4.14 times 10 to the negative 15 electron volts per times seconds. So what are electron volts? They're the energy that any electron particularly has. So 1 electron volt is equivalent to 1.6 times 10 to the negative 19 joules. This is going to be very useful because a lot of the problems you get with the photoelectric effect are going to be in electron volts instead of joules. So just keep these conversions in mind. Now it may be easier to calculate the required frequency to eject an electron using this equation. The threshold frequency is equivalent to the work function divided by Planck's constant. The work function will be given to you for each metal, typically in electron volts, so that's why I suggest using this Planck's constant for any particular problem you encounter here. So let's say we have a metal of work function 8.28 electron volts, and we are hitting it with a light of frequency 3 times 10 to the 15 hertz. So first off, our electron is going to be ejected. Well, let's find our threshold frequency. So we have a work function of 8.28 electron volts. We have our Planck's constant of 4.14 times 10 to the negative 15 electron volts. And if we run through division, we find our threshold frequency is going to be equal to 2 times 10 to the 15 hertz. Our light frequency is 3 times 10 to the 15 hertz, so conveniently, yes, electrons are going to be ejected. What happens if you shine light with lower than the threshold frequency then what happens is no electrons get ejected. You can increase the intensity of the light, but no electrons are going to be ejected. Alternatively, if you have light with frequency above or equal to the threshold frequency, electrons will be ejected, and if you increase the intensity, more electrons will be ejected. So what is the maximum kinetic energy of those electrons that are being ejected? Well, we can use this equation. The maximum kinetic energy is equivalent to the energy of the light, the photon that's hitting the electron, which is hf, minus the work function. So let's find out the maximum kinetic energy of these electrons. We have the energy of the photon, so that's going to be our Planck's constant, 4.14 times 10 to the negative 15 electron volts, times seconds, times our frequency, which is 3 times 10 to the 15 hertz, minus the work function, which is 8.28 electron volts. So let's just put this together. First we do this multiplication, and we end up with 12.42 electron volts minus 8.28 electron volts. And we're left with 4.14 electron volts. And that's the maximum kinetic energy of our leaving electrons. To recap, if you shine light on a metal plate, sometimes electrons will be ejected. This happens if the energy is sufficient to bring out the electron. Now, how do we figure that out? You can calculate the frequency required using the equation. The threshold frequency is equivalent to the work function, different for each metal, but given to you, divided by Planck's constant. Planck's constant is either 6.63 times 10 to the negative 34 joules seconds, or 4.14 times 10 to the negative 15 electron volt seconds. Electron volt is the amount of energy that an electron has, and that's equivalent to 1.6 times 10 to the negative 19 joules. If your frequency of light is below the threshold frequency, no electrons will be ejected, even if you increase the intensity of light. Alternatively, if the frequency is equal to or greater than the threshold frequency, if you increase the intensity of light, more electrons will be ejected. You can also calculate the maximum kinetic energy of the electron ejected using the equation Kmax is equivalent to the energy of the photon that's being shot in minus the work function. The energy of a photon, of course, is Planck's constant times its frequency, and of course the work function will be given to you. Alright, that's all for now. Again, I'm Brian Creer. See you next time.